All right, the first question we're going into is out the book under the category Newton's first law. Newton's first law: an object at rest remains at rest, and an object in motion continues in motion with constant velocity unless the object experiences a net external force. The first question is coming out of page page 128, practice B, determining net force. Number one, a man is pulling. Number three, excuse me. Number three, the wind exerts a force of 452 newtons north on a sailboat. I won't bother to draw the compass. You should know what north is by this time. 452 newtons. While the water exerts a force of 325 newtons west on the sailboat. Find the magnitude and direction of the net force on the sailboat. And most of the questions that we're doing, most if not all of them, involve some form of trig. If your trigonometry is not strong, you need to get it strong. Following Newton's first law, the other vector that I just drew, I don't think I gave the magnitude to it, is 325 newtons. My resulting vector is here. It's asking for the magnitude and direction of the net force on the sailboat. The net force on the sailboat, resolving this vector, I have my A side, my B side, C side. What trig function or what formula can I use? It's Pythagorean theorem. Forgot that I'm supposed to be talking to myself. 452 squared plus 325 squared equals C squared. I squared this entire value. I get my calculator up. 2 squared plus 325 squared equals. Take the square root of that value. Total 556. Total value for this resulting vector is 556 newtons. Understanding that force is a vector, so it has both magnitude and direction. At the resolve for this angle here, this angle theta. The trig function I decide to use, I generally like to use the trig functions that allow me to use sides that were given in the problem, so I can be sure that at least I'll get part of the problem right. The trig function I'm going to use is tangent theta. The ratio tangent theta is equal to the opposite side, the magnitude of the opposite side, over the adjacent side, which is 325 newtons. I'm going to mix this up and erase that A. Make this clear. Solving for theta, I get inverse tangent of this value. I'm doing it plug in the calculator, so I have to write it all the way out. 452 divided by 325. 1.39. Take that value, take the inverse tangent of that. Inverse tangent. Answer is 54 degrees. Second problem. Taken out of the book on page. This is a good theory problem. I've done this already. First, number one, it's on page 129. It says if a car is traveling westward with a constant velocity of 20 meters per second, what is the net force acting on the car? Because of our background in motion, we know that if the velocity is constant, that means that there is no change in velocity. If we recall the acceleration formula is A equals delta V over delta T. And if there is no change in velocity, if velocity is constant, there is no change, that means the change in velocity is zero, which means the acceleration is zero. If the acceleration is zero, when they ask the question, what is the net force acting on the car? Net force
you made it. You made it.
no matter what the mass is, if my acceleration is zero, the net force is zero. Number two on page 129. This is assuming you have a whole physics book. Number two on page 129. Asks the question, if a car is accelerating downhill under a net force of 3,674 newtons, What additional force would cause the car to have a constant velocity? Formula, F equals mass times acceleration. Question, what additional force would cause a car to have a constant velocity? If the car has a constant velocity, that means, again, that the acceleration is zero. If the acceleration is zero and my force is 3,674 newtons, to have a constant velocity, the force that I would have to add to the car is zero. If the car is moving downhill with a constant velocity of 3,674 newtons, having a constant velocity means that I have an acceleration of zero. No matter what the mass is, if my acceleration is zero, then the force involved, the applied force, is zero. I'm gonna make sure. Can I pause this? Yeah. Make sure. Really.
So you're not going over what we went over in class?
This guy just.
No.
How do you find the formula for mass?
And I want to backtrack.
Huh?
Does it tell you? I want to go back to
Oh, you got
like 5:45.
Class.